Greetings. In this video we are going to talk about the area under the z distribution. Let me get this up here on the board for us. Area, try this again. Area under z distribution. So it might be useful for us sometimes to think, and you've probably taken standardized tests, the ACT, SAT, GRE, something of this nature, and they give you a percentile. What percentile was your actual test score? And what they're doing is exactly what we did in the Z-score module, where they're taking your raw score on the ACT, SAT, GRE, and subtracting it from the mean of the sample, dividing by that standard deviation of that sample to get a z-score. And then what they're going to do is put that z-score on an actual plot and then find out what its percentile is, or what the area under the curve is from that point kind of backwards. And so let me kind of walk you through what this might look like, and then we'll use our example from our data set. So let's just draw one basic graph here, just something very simple. So get a better set of axes here. Alright, so we just have something that kind of looks like this. We got our y. Again, as usual, this is frequency. This is, whatever our random variable of x is. And, we have our normal curve. So I'm just going to draw a really small normal curve here. And so whatever the point is, let's just say I'll do it in blue here. Let's just say we get a z-score, and that z-score pops up right here, whatever the value is, but that is our z of interest. And so what we might want to know is, what does that z correspond to in terms of the area right here? So this would be, this right here is the area below the z as a proportion. Of course, then we can take this proportion, multiply by 100, and get a percentage. And so essentially what are we doing? We want to find out right here what this area is in terms of proportion or percent below this particular z-score. Alright, so let's just draw a couple more, maybe little reference graphs here. We'll try to keep them consistent. And so I'm going to get another set of axes here. We're going to draw another small normal curve. And so I'll do this one in blue again. If our z-score was right in the middle, okay, and let's just say that this is a symmetrical distribution curve here, even though I am incapable of physically drawing it this way. We're putting frequency here again on the y. Use the random variable x here of raw scores. And so we know that this zero, the z-score that's in the middle, would be a standardized score of 0. And what that would mean for us is then the probability, or the proportion, of scores that would be above this z would be, this is above, would be 0.500, just written out as a proportion, and the scores below would be 0.500. In other words, this z right here would equal the 50th percentile. 50th percentile. Let's do one more. And then I think maybe one more example or two more examples, you'll have the kind of the intuition at that point in time. Okay? Frequency, random variable x. Let's just say, let's get our curve. Okay, This is my middle point right here. Let's just say now we're going to get a z-score. Let's make it right at the, well, let me label this a little bit better. Let's say that this is 0. Let's say that this is +1, +2. So let's say that we get a raw score that equates to a z-score of 1. So it's going to be right here. Okay, so our z of interest is right here. What's that z equal to in terms of percent? Okay, so essentially what we're asking then is what percent of scores are below here. Whereas over here it was 50% of the scores were below a z of 0. But here on this one, a z-score of 1. Now, where do you find these at? You're going to find these in tables. Now, there is a formula. We're not going to bore you with the formula. It's a rather in-depth formula. When you're using a kind of a sophisticated exponent. But what I want you to understand here is that these are already done and calculated for you, and they're in tables. And you can just look them up. Generally, it's in back of any stats book, and I'm not going to ask you necessarily to do these on a quiz, but I'm just trying to show you that if you had a z-score of 1, then you could simply look this up in a tabled value. And if you remember from the z-score introductory video, between 0 and +1 standard deviation, you were getting 34.34% of the scores. So if you had 34.13 onto 50%, then you know that you would be getting here a z-score that would be equal to point, I'll give you the proportion, 8413. So if you multiply that by 100, you'd get 84.13 percentile. That'd be the percentile that z-score of 1 would actually be at. So 84% of the scores would be below you, and approximately 16% of the scores would have scored higher than you in this particular data set. So let's just kind of label it as such. So from this point, you'd have approximately, and I'm just going to put approximately 16% of the scores would have been above you, and approximately 84% of the scores would have been below you. So let's use our example from the data. If you remember years of employment, we had a mean value equal to 6, a standard deviation equal to 2.71, and I'm just going to rehash the actual z-score formula for us. So if we're going from a raw score to a z-score, what this meant for us was z was equal to, let's use my years of employment, 9 minus 6 again, divided by 2.71 equal a z-score of 1.11. You can plug and chug that math. So what does that mean for my actual percentile rank? So let's get some axes again. There's my x, my y. This is the frequency. If I plot the normal curve, 0 here, 1, 2, 3. Remember, I was at 1.11. Let me switch to blue. So let's just say this point right here was 1.11. That's my z of interest. What does that z calculate in terms of a percentile? What we would then have to do is look this up in a tabled value to find out what percent of the scores were lower than mine, what percent that were higher than mine. Well, I just happen to have a table right in front of me, so if I go to 1.11, what this corresponds to is a proportion. My actual proportion here would be 0.8665. So if I'm just kind of rounding this again, I would say above me, let's just round that up to 87. So above me would be about 13% of the scores, and below me would be, approximately 87% of the scores. And so these are just tabled values, but when you want to know percentile rank, you're going to go to a proportion of the area under the curve table to look up your z-scores, and then that's how you can get your percentile rank. I think that's it for this video. We still have t-scores to cover. Thanks for watching the video.